Hello, everyone. My name is Elisa Baum, and I am Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct just a little bit of house cleaning. Please, would you first raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Okay, great. Thank you. I see lots of hands. That's very helpful. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible. Those that we don't get to will be answered in a follow-up blog post on Percona's MySQL performance blog. In addition, I'll make sure that everybody here receives a webinar recording within 48 hours. And I would like to thank you for attending today's webinar called Percona XtraDB Cluster Operations, presented by Principal Consultant Jay Janssen. With that said, I'd like to turn the floor over to Jay. Jay, you have the floor.
All right, thank you. Can you hear me, Elisa?
Yes, I hear you just fine.
Can you hear me? Okay, thanks. Just double checking. Okay. So welcome to Operating Percona XtraDB Cluster. My name is Jay Janssen. I am a consulting lead at Percona. I've been working with PXC for about a year now. Just got up to speed on it just about when we released it in 2012. This talk is really going to be maybe a little bit different from other talks that on PXC that you've seen. I really wanted to try to do something a little bit different that would be focused a lot more on some of the operational experience that we've had at Percona, helping our customers run PXC in production. Detail. So this is going to be really in depth, and it's really going to try to it's going to assume a lot of things about Percona XtraDB Cluster and Galera that you may or may not already know about. If you're a beginner to XtraDB Cluster, if this is something where you're brand new and you have a lot of questions, how does it work and so forth, you may want to, you're certainly welcome to listen, but a lot of stuff, kind of might go right past you. You may want to go check out some of the other webinars that have been done in the past about, setting up and starting out with Percona XtraDB Cluster. This is one I did about a year ago on migrating to XtraDB Cluster, and then also a tutorial that I gave at the Percona Live MySQL Conference and Expo in Santa Clara in April. This is available on GitHub for free. It's a Vagrant and Puppet install if you're familiar with that, and a list of instructions about how to go through steps in the tutorial, and how to walk through setting up a cluster, how to do all sorts of things. So there's a lot of other options out there for people who are fairly new to Galera and to XtraDB Cluster. This talk is not necessarily geared toward you. So that being said, let's jump right into some configuration best practices that we see with PXC. Innodb tuning, first and foremost, you should be using Innodb with PXC. If you're not using Innodb, you probably are using the wrong product. PXC is completely designed for Innodb for any kind of high performance. So how do we tune Innodb? What are some things we need to keep in mind? Well, the good news is that it's actually pretty easy. If you already are familiar with Innodb tuning, nothing changes a whole lot. I mean, you tune your buffer pool nice and large. You need to set your transaction logs to an adequate size, et cetera, et cetera. This isn't going to be a talk on how to tune Innodb, but there's lots of other resources out there for you that are available on tuning Innodb. I might recommend High Performance MySQL 3rd Edition, which are some people at Percona wrote. One thing I would just call out, you do want to watch your buffer pool memory utilization. So when you allocate RAM usage on an Innodb server, typically you'll want to give as much RAM as you possibly can to the buffer pool. My rule of thumb is as much RAM as you can without swapping. But when you go from a standalone server into using Galera and PXC, you have to expect that Galera is going to use a little bit more RAM on your system than you might have seen in a standalone setup. So generally speaking, we see people switch over to Galera and then maybe they start swapping a little bit. So you just dial back your buffer pool settings a little bit. Also, the question comes up a lot about what do we need to do with data durability? Do we need to set Innodb flush log at transaction commit or not on our cluster? The answer to this, of course, is that it depends. It depends on what your requirements are, but in general, for single node data durability protection, the cluster protects you against losing data on a single node crash. So even if you are connected to a given node, you're writing on that node, and you do a commit, as long as that commit has been sent to the cluster, then if that node crashes in the next instant and restarts, it will still be able to retrieve that transaction from the rest of the cluster and recover itself. So in general, flush log a transaction commit, protecting yourself against single node failures is not as big of a deal with PXC. That being said, if all of your cluster nodes are, for example, in the same rack, plugged into perhaps the same UPS or power source, and there's a possibility that all of the nodes could go offline at the same exact second, then you may have the possibility for data loss if you do not set flush log a transaction commit equal to 1. In addition, the replication, of course, the replication is sending the transaction to all the nodes, and all the nodes are applying and also committing, and that commit does take flush log at transaction commit into effect, both on the node that you originally write on and all the nodes that receive the replication. So it can sometimes cause a bottleneck, like with standard replication, in write throughput and replication throughput. So some people want to leave it at 1, that's fine. If other people set it to 2 or 0, that's also fine. It really just depends on what your business requirements are for data loss. The questions also come up about things like Innodb checksums, using the Innodb double write buffer. These are systems that are baked into Innodb, again, to protect the consistency of a single node in case of a crash. And it's all about making sure that the pages on disk and the Innodb table spaces are consistent. So I think in theory, you certainly could disable these and say, look, if one node in the cluster ends up with a corrupt page, it's not the end of the world because it can just go SST and so forth. Do realize, though, that corrupt pages in Innodb will crash that node. So you are going to have a crash. You are going to have an SST. You should expect that if you're going to disable these. In general, I don't think, we're not recommending right now that people do disable these. That's going to be really in a high-performance situation where that would make much difference at all. So it's definitely conceivable. It's not like corruption should be propagated through the cluster via replication or anything like that. But in general, it may not be really worth the performance gain to disable those. There's also Galera prescribed settings for Innodb. You're probably familiar with these if you've set up PXC before. Innodb locks unsafe for bin log equal 1. This is a recommended setting. It used to be required, I believe, and now it is actually just a recommended setting for performance. It's reducing the amount of locking that Innodb is doing. And also, Innodb auto ink lock mode equals 2. This is a setting that technically you only need if you are using parallel replication in Galera. So that's generally, the Innodb tuning, the things that you want to focus on. Now, what about the general server overall? Well, of course, bin log format equals row. This is something that is a required setting in all the default tutorial setups and so forth. But if you are using asynchronous replication at all, you should enable log slave updates. So that is, if you are using asynchronous replication into the cluster, one of the cluster's nodes is a slave, or one of the cluster nodes is a master to some other asynchronous slave, then log slave updates is your friend. That will guarantee that writes coming into the cluster via replication is replicated to the whole cluster. And then also, if you're replicating out of the cluster, that all writes to the cluster are replicated out through that master to the slave. So it is important to remember to enable that if you use any async. Also, it may not be immediately obvious, but Galera has sort of this weird relationship with replication configuration items in MySQL, like log slave updates. And that also comes out in odd places like replication filters. So if you have replication filters where replicate do DB, replicate ignore DB, things like that, that will actually apply in Galera, but it's probably not going to be what you want to do. Everything about Galera and PXC is assuming that all the nodes have all the data, they're all consistent. Things like SST are designed to just copy everything on the node over to the other nodes. There's really not any kind of design in the system to have different data on different nodes. So if you inadvertently leave things like replication filters on your cluster, you may end up with very surprising results and very actually a very dangerous or high possibility of data loss. So be very, very careful there. I've also seen a case where people have slave skip errors enabled, and this is just from some historical configuration. They were skipping duplicate key errors, and lo and behold, when one of their nodes in the cluster became inconsistent, Galera was not able to detect that because it relies on a slave error being thrown, and so it can abort the node and trigger an SST. And so that was happening. It was just being skipped, and the cluster was not able to operate properly. You also do not want to use the query cache. That is unsupported by PXE and Galera at this time. It's a question that comes up probably about every month or so on the mailing list, and it's just not supported. If you're using the query cache in 5.5, you're almost certainly doing something wrong. The query cache scalability and performance is just really being outstripped by Innodb at this point in MySQL's history. There are probably a few use cases where it does help, but it generally is not designed to be used for PXE, and I think there's at least one open bug about this. But otherwise, generally speaking, you're going to do normal tuning on the server, max connection, thread caches, table caches, all that kind of stuff. It's going to be pretty much the same as you would tune for any other regular master slave. So the good news, and the nice thing I like about PXE is that it is relatively easy to set up and tune. Of course, this is me saying that after a year's experience doing it, but that's just my opinion. There's not a lot of tuning that you have to worry about. So let's talk a little bit about network. If you have a network that is you're doing synchronous replication over, you have to be a little bit more sensitive to network bottlenecks and replication and network throughput. The reality is that synchronous replication is using the network as the medium of transport and group communication between all the nodes, and if that resource becomes congested, then you are much more susceptible to cluster problems as a result of it. So I see most people are using gigabit network these days, and the theoretical maximum is 120 megabytes per second, which sounds like a fair amount of data, but is that enough for all the replication that you're doing? So just the standard Galera replication, I write on one node, it replicates to all the other nodes. That is going to multiply the replication event by, all the other nodes in the cluster. So you write on one node, so say I have 5 nodes total in my cluster. I need to multiply that that replication is going to cost 4 times the bandwidth because those messages are going to be sent to all the nodes individually by default. Now, I would point out that this is the same as it is in asynchronous replication. Asynchronous replication, all the slaves all have their own individual connections to the master. But because this is synchronous replication, this obviously is a much more sensitive situation. Now, compound that to the fact that, well, what if you're running everything over the same network? You have one network interface card on every server. You have 1 gigabit network that's basically shared across all of the services on the box, and that includes the application connecting to MySQL. So that's queries coming in, data going back out. If you're sending a lot of data from your queries, that can start to add up quickly. Also, what about if your cluster does the occasional ISD or SST? Generally speaking, those are going to go as fast over the network as they can, particularly the ISD, which is memory-based. So that's just going to basically broadcast and blast the network as fast as possible. SST is going to be generally a little bit more constrained by things like disk I/O reading off of the donor and sending data to the joiner. But overall, you want to be careful. If you're writing kind of close to the threshold, an IST might push you over the edge, and you might see transitory network issues or cluster problems, even though normally when an IST or SST happens, even though normally it's actually fine. And then, of course, asynchronous replication as well. So if you have any kind of other slaves off the cluster or into the cluster, that is going to add up to your total bandwidth consumption. So what are some things that you can do to mitigate this? First of all, multicast. I did a blog post on this a month or 2 ago. Switching to multicast is an alternative if your network supports it. Probably it's only going to be a viable situation in a LAN environment. And that will, instead of sending the replication message to all the nodes, it will broadcast out the message via multicast, so it reduces the consumption of the network. Also, SSL and compression is another possibility. I haven't experimented with this too much, but you can enable SSL for the group communication between the nodes and apply compression ciphers to that, so that's also a possibility. And you can also assign different networks to actually all of the things I listed above. So the application MySQL client server can be on one network. The Galera replication can be on a separate network, and then IST and SST would be on their own networks in principle. In practice, I usually see people having one front-end network that handles client-server traffic from the application, and then another network that's dedicated just for PXE replication and IST and SST. If you do that, then using the Wsrep node address configuration to specify the secondary network for Galera related is a handy way to configure that second network in your my.cnf. So let's talk a little bit about tuning replication and what that means. Tuning replication, there's actually a bunch of different ways you might want to tune replication, and this starts to sound a little foreign to MySQL because generally speaking, there really wasn't much tuning you could do to replication in the past. But with Galera and PXE, we can tune for things like, well, we want to make sure that writes to the cluster are very fast, and that would typically mean that there's writes with no pauses for flow control. So I'll talk a little bit more about flow control in a little bit, but we don't want the cluster to pause and basically stop accepting writes for any period of time so that our application doesn't experience any kind of write outage. We also may want to tune for fewer write conflicts in the cluster. If you're multi-node writing, it is very possible for you to have write conflicts across the cluster where clients connecting to different nodes try to update the same records at the same time, and one of those, the first commit is going to win, the other ones are going to get a deadlock error while those the first one's transaction is still in flight. So that would generally mean fewer certification failures and fewer brute force aborts. It is possible to tune for that. Also, we may want to tune for fast reads from the cluster, but again, that sounds a little weird because usually we expect our reads are always fast, that they would be as fast as Innodb, but the flip side of that might be consistent reads from the cluster. So we want to ensure that the node that we're connecting to at a given point in time has actually been committed in the replication stream, has been committed on that node, so when we read, we know we have a consistent read view from maybe another node we just wrote to. So these are sort of some of the dynamics we could tune replication for, but how would we actually do that? So some of the mechanisms that we have available to us, and these are things that are distinct with Galera and PXE, first and foremost is flow control, I mentioned. And what flow control does is it pauses writes on all nodes when the receive queue, the inbound queue, gets too big on any one node. So I've explained this in other more introductory classes to Galera, but the Galera replication is synchronous up to a point that on commit, you are guaranteeing that the transaction has reached all the other nodes in the cluster and that all of those nodes will be capable of committing that transaction, meaning no other transaction at that point will be able to supersede that transaction if it replicates and certifies. But what that doesn't mean is that the transaction has actually been committed on all those nodes, and indeed it hasn't. There's still an apply queue. There's still potential for some lag there, and that's where flow control comes in. It's trying to ensure that given nodes just don't start falling arbitrarily far behind the rest of the cluster, that they all keep up into a pretty tight constraint. The way that you tune that is in the Wsrep provider options. The flow control limit, FC master slave, and FC factor. I've done some at least one blog post on this in the past quarter or so. I'm not going to explain exactly how they all work, but effectively you're setting a limit and saying the inbound queue, the receive queue on this node, the limit is this. And once we cross that limit, we're going to invoke flow control. And any node in the cluster can invoke flow control and pause the entire cluster. Another mechanism for tuning replication is going to be parallel apply. So that is the Wsrep slave threads, and that allows us to apply pending transactions in the receive queue faster. I would point out, though, it's not necessarily obvious. All of the transactions go through both an apply and a commit phase. The apply phase is actually modifying the changes, and then the commit phase is the actual thing, the logical step at the end in Innodb saying commit, and that actually does the flush log of transaction commit to your redo log. Apply can be parallelized. You can have multiple transactions applying as long as they don't have any dependencies. But the actual commit part of that at the end is serialized by global transaction ID. So it can be the case that you have, say, 16 apply threads, but they've all applied the transaction they have, but they're waiting for some transaction ahead of them to finish applying and commit first. So it's not perfect parallel apply, but it's definitely much better than any other competing replication product. Also, another tuning mechanism is causal reads. Causal reads doesn't sound like a replication tuning, but it really is. It pauses selects on a node until its receive queue flushes. And I don't mean that the receive queue goes to 0, but I mean that at the moment that the select is issued, effectively what happens is a bookmark is placed in the queue. Say the queue is 10 transactions behind, and as soon as those 10 transactions finish committing, then the select will be run. You can control this with the variable Wsrep causal reads. This is also a session and a global variable, so you can actually set it, if your application is aware of Galera, it can set that as needed for critical reads and turn it off otherwise. But you can imagine that that will potentially slow down that read quite a bit depending on how far behind the queue is. Now let's take these mechanisms, flow control, parallel apply, causal read, and put them back to the different replication tuning goals we might have. If we're tuning for fast writes to the cluster, we are probably going to we don't want flow control to happen. So we might say, okay, well, let's just turn the flow control really high. Let's set the FC limit to 1,000 or 1,000,000 or something like that. But that actually conflicts with the goal of having fewer write conflicts if you're multi-node writing. The larger the receive queue is on a given node that takes a write from a client, the longer certification, well, certification won't necessarily take longer, but the more likely that certification will fail and you will get a local certification failure. So more flow control, or more relaxed flow control, larger receive queues, more write conflicts. If you tune flow control down, then you may have more flow control, but you'll have fewer write conflicts. So it's really, a balance between the two. The default FC limit, I should mention, is 16. There's a slight modifier if you read up on how the FC master slave setting works. So generally on a 3-node cluster, your practical FC limit is something like 27, and that's transaction. Now think about if asynchronous replication, if you had the ability to tell asynchronous replication or prevent asynchronous replication from getting more than 16 or 27 transactions behind, you'd probably be really happy. When asynchronous replication gets behind, it could be minutes and it could be hundreds or thousands of transactions. So by default, this is tuned really to prefer fewer write conflicts, but you can adjust it, particularly if you use a master-slave type cluster where you're only writing to one node. Well, what about fast reads versus consistent reads? Like I said with causal reads, the causal read is going to slow down selects in favor of waiting for the queue to flush. So, do you want it fast or do you want it consistent? Now, imagine if you had your FC limit set really, really high and your queue was behind, say, by a couple hundred or 500 or 1,000 or more. Guess what happens on consistent read? You're going to have to wait for all of those transactions to get flushed. So you can't have everything here. You have to kind of play the balancing game. But one of the really great things about DXC and Galera is that we have the ability to make some of these choices where we never really had these decisions before. Okay, so let's move on to our next section. That's going to be about monitoring. So one of the biggest things I wanted to talk about, and this is a follow-on from the last section, is monitoring flow control. I would say that this is a healthy share of the quote-unquote my cluster is hanging. My cluster just stalls. Reports that we will get, it's really flow control kicking in for some reason or another. So it's really important that you understand how you monitor flow control. First and foremost is the Wsrep flow control sent. These are all show global status variables. Flow control sent is incremented on the troublemaker node in your cluster. So the node that is causing flow control is going to send flow control messages out to the rest of the cluster. The opposite of that variable is the receive variable, and that is going to be the recipient of trouble. So basically, one node will send out a flow control message, everybody else will receive that message, and you'll see that indicated in these variables. And then in addition to that, there is Wsrep flow control paused. This is the percent of time paused from between 0 and 1. So you say like 0.5 would be 50% time paused. But you might be wondering, time paused since when? Well, it turns out none of these are actually global counters. None of them increment from 0 to some very large integer for the length of the server, they actually all reset every time you run show global status. So flow control pause, this kind of makes sense. You say, okay, I do flow control pause once a minute, and I get a 0.5 there. I know that flow control was in effect on that node for 50% of that last minute. Fine. But for flow control sent and flow control received, it's a little bit more difficult because now, as soon as you run show global status, the fact that this node sent a message and this node received a message is now lost. So I personally think those first two, at a minimum, should be global counters, and they should just always increment. So I can tell, hey, over time, this node sends more flow control messages than anybody else. Maybe that's my, I should figure out what's slow on this node. And also, it just makes it work like every other show global status variable that exists. And then for flow control pause, I'd really like to have, honestly, just a total time spent in flow control pause globally. That, of course, I can, do rates on and things like that. If you agree with me, please go to Launchpad and go to this bug and click the This Bug Affects Me link so that we can prioritize fixing this and getting this enhanced. I think it would make things a lot easier to have visualization. Now let me show you an example of what I mean. Here's a couple of nodes. It's a 3-node cluster. And node 1, I'm doing a show global status like Wsrep flow, so I'm seeing my variables. Everything's set to 0, looks good. On node 3, I'm doing flush tables with read lock. Now what flush tables with read lock is going to do is prevent writes from happening on node 3, and that's going to fill up node 3's receive queue, and that's going to invoke flow control. So if I wait a few seconds, I have writes happening on this cluster, and I go back to node 1, I can see, okay, flow control pause is 18%. Well, 18% since when? Since the last time I ran it, I guess. That doesn't necessarily tell me a lot, but I can see, okay, flow control received is 1. But if I run it again right away, all right, I see flow control pause goes to 1.0, so I know that this is 100% of the time that the cluster is basically wedged. But now my flow control received counter went away. So this makes it a little bit confusing sometimes to monitor this. Honestly, I didn't even know that flow control sent and received weren't global counters until a couple months ago. So it's one of those things where if you're not aware of it, it may cause a lot of confusion. Like, oh, we had flow control, but I don't know why. Nobody sent it. Well, they did. They just lost the precision there. Another side hint here, flush tables with read lock will lock your cluster via flow control. And some people don't expect that, like hint, hint, if you're taking a backup. So MySQL dump with locked tables, or even Xtrabackup does the flush tables with read lock, and so that is going to potentially cause flow control issues on your cluster. So let's take this a little step further in monitoring our variables. What does this tell you? If we look at Wsrep received, this Wsrep received is a count of all transactions that have been received from the cluster, replicated from some other node in the cluster. And then we have received bytes, which is the count of bytes. So we have 2 runs of this, and we can see, okay, we gained 3 transactions. We went from 1567 to 1570. And then our received bytes went up quite a bit. We had about 2 megabytes of received bytes, and now we're up to 56. But we don't know a few things. We don't know how long this took unless we, actually counted and ran this systematically every second. And we don't know which of those transactions had all the data. Was it all of them? Was it just one of them? We're not really sure. Now, what if we compare that to this? If you've been to any of my talks before, I pitch MyQ status all the time. It's part of my MyQ gadgets package. It's available on GitHub for free. I use this every day in consulting. And this is basically like IOStat for MySQL. And what we can see is instead of just sort of arbitrary global counters, we can actually see rates over time on consistent intervals. So it's a lot easier to see what's happening. Now, what I want to point out here is we can see that large transaction going through in this case. We can see the bytes down. That's the received from the cluster. And then we can see up, which would be replicated out. So this node is just receiving writes from the cluster. And we can see kind of a consistent down pattern, 14 kilobytes, 7 kilobytes. It kind of jumps around a little bit, but it's more or less in the same ballpark. And then all of a sudden at line 12, we can see a big 52 megabyte something come in from the cluster. So that's a huge change in the amount of data that we're receiving. Now, once that happens, we notice that the receive queue is doing some interesting things. The down queue is doing some interesting things. We see some queuing there. We see a little bit of a pause after it receives it, this is actually certification happening. So the transaction is being certified in this node that is effectively preventing anything else from hitting this node. And then that is, as soon as that's certified, we see the receive queue jump from 1 to 29 and 30. So that in our 3-node cluster is pushing us past our flow control limit. And so we can see a flow control sent, the SNT column, about 2/3 to the right. We see one flow control message sent. We see for a few seconds that that transaction is basically applying. It's applying and then committing, and then as soon as it commits, we see line 18, the receive queue just all of a sudden flushes, and we see more flow control messages sent. Those are releasing the flow control, and then our cluster proceeds normally. Now, there's a few things I want you to take away from this. One is that it's certainly much easier to read rates when you've got global counters. Most show global status variables are global counters, so it's very handy that you have tools that you can see rates on, the rates of change over time. Secondly, per-second statistics should not be underestimated, particularly when you're having performance issues that you're not sure what's going on. If you were graphing these statistics on a per-minute or per 5-minute basis, you would not have seen that happen. You would not have seen that pause. You might have seen that there was some flow control, but you wouldn't really know why. From this, it's really, really clear that it was a large transaction that caused this problem. And oh, by the way, large transactions are problematic in PXE, and this is kind of why. So that's one of the big points I want to make about monitoring is make sure you're looking not just at the long-term trends, which are important, but also be prepared to look at the per-second statistics. So what about monitoring plugins that are out there in the wild for Galera and PXE? Well, there is at least one Nautilus plugin, there may be some more. I found this one on From Dual that somebody had put together and to do some monitoring. You can have a look at it and evaluate. I'm not vouching for it. I'm just saying that it exists and it may be helpful to you. In the Percona monitoring plugins, we're lagging a little bit behind here. And in our Nautilus plugins, you can use the MySQL status check, which will check any kind of arbitrary global status variable against any threshold you specify. So you can do a fair amount of good monitoring of Galera with this check, using some examples in this gist on GitHub that I put together. And on the cacti template side, well, that's been coming any day now for a little while, but we're looking for contributors. So if you are interested and know anything about cacti or actually any other monitoring system graphing templates that something we could open source and we could send people to, that would be wonderful. And please reach out to me. I would be happy to encourage and help with my ideas. Also, we're looking for people who would want to sponsor the development of some of these things for our internal tools. Ultimately, I have a list of things that I would like, some specs on some graphs that I would like to see. I'm just not brave enough to delve into the world of cacti templates yet. So from the graphing side, if you're interested in any ideas I have, I'd be happy to share those with you. I've no qualms about sharing those. Some other tools, at least one other tool that's worth looking at, if you're interested, is Cluster Control by Several Nines. They have a Galera version of their cluster control panel, and so it's like a control panel for your cluster. You have monitoring and maintenance operations and so forth that you can do with it. It is a licensed product, but the free version allows you to do monitoring, but no maintenance operations is my understanding of the delineation there. So that may be useful for you if you are if you're interested in having a nice visual dashboard for your cluster. Okay. So next fun topic: how do we avoid SST? We had at least one customer who had like a terabyte data set. And as you can imagine, an SST in a terabyte data set is kind of a painful thing, and you really want to be careful that you do everything you possibly can to not have to go do an entire backup, especially if you have a 3-node cluster. You got a 3-node cluster, one node decides it needs SST, that's a joiner. It's got to go pick a donor. The donor's got to be occupied for however long it takes to copy that data set, and you're basically down to one node, which is obviously not ideal. So how can we avoid that? Well, I submit this to you. Whether or not a node is going to be capable of IST completely depends on this little file in your data directory called the graph_state.dat. The graph_state.dat is effectively going to be in one of 4 possible states. I'm going to explain those to you. And then depending on the state, it's a question of whether or not SST or IST is even possible. I will also add that IST, even if the gross state is in the perfect state, IST might still fail if the donor selected doesn't have all the needed write sets. And unfortunately, right now, Galera does not do intelligent donor selection based on the write sets available. So for example, if you have a couple of nodes that went down, you restart one, it ISTs, and then you need to start a second one that needs transactions that maybe that one went down before the first one you restarted, and it picks the first one you restarted as the donor. It may not have all the transactions it needed because all the transactions are stored in something in the Gcache, if you're familiar with that, and that is memory-based. It's not preserved across restarts and crashes. So that aside, control over the gross state. Now, the 4 different states. First and foremost, if the gross state is missing, usually that's because this is a node you're restoring from a backup, something like that. The file's just not there. This wasn't a Galera node. So unless you're bootstrapping your first node, then if the gross state's not there, you're going to SST. There's no way around that unless you go hand edit the gross state.dat. If you are restoring from a backup to rejoin a node to the cluster, you can run Wsrep recover to gain a position. I'm going to talk about Wsrep recover in a minute. To get the position in Innodb that you can recover from, and then you can if you handcraft your gross state.dat, then you can use that to actually avoid SSTs by using backups. Second state of the gross state.dat, you have a UUID of all zeros and a sequence number of -1. Now, these two numbers, for those who are playing at home, comprise the GTID for Galera. It's the UUID is the cluster state, and then the sequence number is the count of transactions. So a gross state in this particular state is typically caused by Wsrep abort, which is MySQL crashing, Wsrep being able to throw its exception handling and flush out the gross state. The standard use case for this, and the reason why it does this, is that this is a signal to the node, hey, you should SST. And if that was caused by a row-based replication error, then you should probably let it SST because that's an indication that your node is out of sync. It's inconsistent. If you have a row-based replication error from some other node, then that means that you're missing some data that they have or have some data they don't have. Something's wrong. If it's not a row-based replication error, like let me give you an example of something else that causes this. Misconfiguring your my.cnf. So you type a bad configuration parameter in your my.cnf, you restart the node, it fails with an error saying, I don't understand this variable, and then you go to restart it, and whoops, we have a zeroed gross state.dat, and we're going to SST. This has bitten me more than once. So if it's not a row-based replication error and some kind of consistency error where it makes sense to SST, then I would go hand edit my gross state and possibly using Wsrep recover if I need to. Third state, our UUID is set, but our sequence number is -1. Now this is the state of the gross state when the node is a node is running. It does not update the sequence number as transactions come in. The sequence number is just set to -1. So this is typically, if you see this and the server's not, the node isn't running, typically this means that the node was kill -9, or if you had a power failure, kernel panic, something like that, that abruptly stopped MySQL operation without giving it a chance to abort. Right now, this is the only time that IST will happen automatically with Wsrep recover, and I'll talk about Wsrep recover in a little bit. But if you do have this, and you start up your node with modern versions of PXE, Wsrep recover is actually run every time PXE starts, and it will attempt to populate the gross state, but it will only do so if the gross state is in this state. And then it will figure out a sequence number, and it will try to do an IST. The final condition is you have a UUID and you have a sequence number. This is typically the result of a clean shutdown because you shut down the node cleanly. When that happens and Wsrep exits cleanly, it writes out this gross state, hey, here's the last transaction that I got. When you restart, then you shouldn't expect an IST here. Again, only as long as the donor you connect to has all the transactions that it needs. All right? So that being said, what does a Galera abort look like? It's useful to know what this looks like. And in my tutorial, I do some examples of this so you can actually see it happen. But if you kind of track through this, this is the error log. We can see could not update rows event on table SB test 1. So this looks like a slave SQL. This looks like a standard asynchronous replication error. And it is basically the same error. It's an RBR event for update rows apply warning. So this is row-based replication going through Galera, so it's the same error messages. We couldn't apply the transaction, line 4. And then so line 9 tells us what it's going to do. Our node consistency is compromised. We're aborting. And if we go look at gross state after that, indeed, the gross state has been zeroed. And this is the second state I talked about, and this is the state I mean when I say the gross state is zeroed. So this is SST by intention. Wsrep recovery now, it is something that is run in MySQL D safe before it starts up the main MySQL D. And it actually, confusingly, is run with MySQL D. So you run MySQL D --Wsrep _ recover, and that will spit out a Galera position. So MySQL D safe, that's used by most init scripts, is going to run that first every time. It's going to submit that to the second invocation of MySQL D, passing it with the Wsrep start position. Now, where does it get that position from? That position is actually being stored in the Innodb logs. And that sounds really clever, right? Because Innodb logs are transaction safe, or Innodb is transaction safe, and it's because of these logs. And so everything that was committed in the log is also going to be synchronized with the Galera GTID. So this sounds really clever. However, anything that's not Innodb, it may not be accurate for, it may not be consistent for. And the reason for that is things like DDL, MyISAM, et cetera, are not transactional. And so if you recover a position from Innodb, if there was a DDL happening, you may not have it all. You may not have any MyISAM changes. So this is one of the reasons why you really want everything to be Innodb, as you can imagine. You also generally want a cluster that's you're not doing DDL on most of the time. But that's a separate discussion. So once it gets this position, it passes it to MySQL D with the Wsrep start position option. And as I mentioned before, that only actually does anything when the gross state has a set UUID but an undefined sequence number, a -1 sequence number. I am lobbying to have this also apply in the case where the gross state is completely missing. I mean, I can see the argument that it's undefined in that case, but I think it's worth a shot. So there's another open bug on that. I don't have the link right here, but you could certainly go find that out and comment there if you have any other feedback on it. Okay, so some other miscellaneous topics that may be worth us talking about briefly. Application stuff, particularly high availability. This is a pain point that I've seen with a lot of production deployments. We kind of throw the cluster into production and not give a lot of thought about what the application should do in the case of things like donor nodes. So donor is generally an SST, although it can be an IST as well. But on SST, every SST method currently blocks, even Xtrabackup blocks, even though it may be for a little while. So do you want that node in production potentially taking writes and or reads, or possibly getting desynchronized from the cluster? That's an interesting question. I should also add that donor nodes go into a state where they do not send flow control. So if they start getting behind, that is permitted by the cluster because it's expected that they're donors and they're probably going to be taking a lock at some point. So that may not be the best thing for your application to connect to. What about rolling cluster restarts? What is your application going to do when each node in turn, gets restarted and then comes back online? Can your application handle that gracefully, particularly if you do things like persistent connections? So you might have HA proxy or some load balancer, but if those are all persistent connections, it might be additional operational overhead to go in and say, okay, I have to go take this thing out of rotation, but while it's still up, kill all the connections so that they redistribute and then restart it, and then do the same thing on the next set of nodes. So I find that this has kind of been problematic for some people. I'm not necessarily recommending non-persistent connections because if you have a really, really high request rate, then your connection rate is going to be also very, very high. But I think it may be a good thing to stick in your database connection libraries, maybe to disconnect periodically, maybe after every minute or two. So you do have something that's like non-persistent connections, but without quite as much overhead of a lot of TCP connections being set up and torn down all the time. Also, what about multi-node writing conflicts? If we're writing to multiple nodes and we start to get all these deadlock errors, how should we track that down? Well, first and foremost, I think it's important to log those. When you get deadlock errors on your client side, this is a great thing to put in your client library for your application logs. Log those. Like, hey, we got a deadlock here, we got a deadlock there. If these are writing conflicts and not real deadlocks, then PT Deadlock Logger isn't going to help. This is a tool in the Percona toolkit. This only logs real deadlocks from Innodb. The deadlocks that Galera returns are really, somebody's called them before landlocks or WAN locks. You know, it's something else happening on the cluster that's conflicting with what we're doing. So PT Deadlock Logger isn't going to help you there, but you can enable Wsrep log conflicts, which will log information about the transactions that were aborted in your error log on that node. So that can be helpful to track down. Usually there's hotspots inside of your database, that your application workload against your database, that where there's a lot of writes and changes to the small set of rows, and this can be these techniques can be a very helpful way to figure out what those are, so you can try to figure out how to work around them and reduce your multi-node writing conflicts. What about backups? This is another big topic that I've heard a lot. I mentioned already, Xtrabackup takes a flush table with read lock at the end of its run by default. So it's doing that for table schemas and non-Innodb things like MyISAM, as I already mentioned, right? Those things are non-transactional. So, you know, the backup from Innodb, while that can be perfectly hot, everything else to make sure that's consistent with our Innodb backup, we have to take that flush table as read lock before we finish. As a side note, if you do this and you have a lot of tables and schemas, --rsync is a really nice way to minimize that time. It starts copying those non-Innodb things during the Innodb copy and then takes the lock and does one final rsync at the end for anything that's changed. So that's an aside. If you do have flush table with read lock in your Xtrabackup, because you're backing up, you know, you want to back up the data in your cluster, that's going to fill up your receive queue, unless it's a very, very fast flush table with read lock or you have very low write volume. And if that does fill it up, then of course then you're going to trigger flow control. Now, I mentioned before, donors don't trigger flow control. That's kind of the difference. So they are allowed to get behind, but currently there's no way to tell a node become donor. It's actually the full state is actually donor/desynced, and that allows nodes to become arbitrarily far behind. But that's only in that special case. There is actually an open bug discussing the ability to make a node a donor explicitly with a set global command. But again, I'm getting off topic. So if you're trying to take a backup, my question would be, what are you trying to do with this backup? There's two things that I can think of. One would be, well, if the entire cluster just freaks out, maybe the data center then goes completely offline, so it's a disaster recovery type scenario. You know, you want to rebuild the whole cluster from this backup. That's one use case. And then another use case might be, well, I just want to be able to use a backup to rebuild nodes without SST. Now, if you're doing that, the second one, you're going to need to have probably pretty frequent backups or very large G caches. Otherwise, you're not going to be able to IST anyway. But I think most people who do backups are really looking for the former. And so if it's only a disaster recovery backup, then you don't need the GTID of the cluster. Why? Because you're only going to use it when you restart a brand new cluster, and you're just going to bootstrap it and ignore the GTID anyway. So you don't need to use the --Galera info option in Xtrabackup. And if you don't need that, and you don't have like a bunch of MyISAM, and you don't have any table schemas, then you might be okay with running Xtrabackup with --no lock, which, as the name implies, does not take the flush tables with read lock at all. Now, there will be a race if you have any DDL or MyISAM replication going on, but if you don't, your schema is 100% Innodb, you're not making any regular changes to your grant tables and so forth. My supposition is you run Xtrabackup, Innobackup EX --no lock, you don't get into a lock state, you don't have flow control, and you can take a nice clean backup off your cluster that you can use for disaster recovery purposes. That's my take. You certainly could use it for restoring those without SST, but again, you're probably going to need more frequent backups than just like daily or weekly types of backups. Okay, so that's pretty much all I have. Resources that are available to you, the XtraDB Cluster Manual. Codership's wiki has a lot of good information on it, even though some of it's a lot of date. They've been updating a few things. There's some good stuff there. Percona XtraDB Cluster tutorial that I wrote and delivered in a few times now. That is available for you on GitHub for free. Also, anything on the MySQL Performance blog in the XtraDB Cluster category is a great thing to read. I try to publish under that tag. Other people do as well. If you want to get on a mailing list that is dedicated to Galera, the Codership Team Google group is a good place to go. It's pretty active. Lots of good people. A lot of people outside of Percona and Codership who are working with PXE and Galera in production. So that's a great place to join if you want to be part of that community. And then also our Percona forums. I try to answer questions here from time to time in our XtraDB cluster section. So with that, I am done. I got about, I guess, 10 minutes. So Elisa, are there any questions?
Okay, thank you very much. Can you hear me, Jay?
Yes.
Okay, great. Everyone, if you have any questions for Jay, please go ahead and enter them into the questions panel in the GoToWebinar control panel. And Jay will take as many as he can for the next few minutes, and then anything that he doesn't have a chance to answer, we'll make sure that is answered in the on the MySQL Performance blog. Okay, so Jay, the first question is, how do you get around the default heartbeat error? We haven't changed it and tend to crash a node due to heartbeat issues.
So heartbeat issues, it's a good question, and I have not spent a lot of time tuning in this area. There are different timeouts. All the node failure inside of Galera is timeout based, meaning that if the cluster stops hearing from a node for a certain period of time, it's going to start to suspect that that node has failed, and then it kind of goes through this whole process of evicting the node and you know, quorum elections and all sorts of things. And if you have a network that is possibly saturated or having, you know, bandwidth constraint issues, or you have a lossy network, maybe it's a high latency network like a WAN, it might be the case that you'll need to tune some of those variables. There's some good information on the Codership wiki that talks about, you know, tuning things you might want to tune for a WAN cluster. So if that's your situation, that might be something worth you know, worth looking into. Beyond that, you know, if you've kind of played around with those and haven't had any success, then I would take a look at the network and just look to see, is there packet loss? Is there, you know, what are the switches doing behind the network? Are they getting saturated? Are they getting bogged down? Something like that is an interrupting group communication, and of course that's really vital for the cluster to perform well.
Okay, the next question is, do we have any comparison between XtraDB Cluster and the new MySQL Cluster version?
Not at all, and the reason is that it's completely apples to oranges. MySQL Cluster product is, I think, unfortunately named. I mean, it's a really great product. It's a really cool technology, but it's really a different design from PXE. NDB does its own internal data sharding. It runs its own set of independent data nodes from MySQL. It does its own sort of, you know, there's multiple classes of node. It's really a much more complex product, and it's something that has been really designed for very specific workloads. PXE, on the other hand, is not a sharding cluster. It's all the data is on all the nodes. You're not going to, you know, scale infinitely by just throwing more nodes at this in terms of data growth, and it's really meant to be much more like standard Innodb. So, you know, there's a lot more differences in that, but we don't have, you know, anything to really compare it because it's really, how do you compare them? That being said, I know that there's been some good work done in MySQL Cluster recently. The new release had some really good things in it. Generally speaking, that's not something, how shall I say this? We have MySQL Cluster experts, but we're not seeing a lot of growth in that area. Let me just say that, for what it's worth. So I guess that's the best way I can answer that question right now. Would be happy to do some testing for you if you're interested in you know, bringing us on to do some benchmarking and so forth to try to help you analyze some performance, but really they're very different products.
Okay, next question. Is there a chance to have a cluster node with quorum less than 50% read only, but to stop operation?
Currently, that is a great question. No, there is no way to do that currently. So if you have a node, let's just say you have a multi-data center cluster, let's say it's 3 colos, you have one node get isolated from the rest of the cluster, some kind of WAN link problem. That node is going to go into a non-primary state because it does not indeed have quorum, and non-primary means no reads, no writes. It would be, I think, an interesting feature request, and maybe somebody's already made the request to say, look, I want non-primary to mean I can read, but I can't write. Currently, that's not how it's implemented, and I'm not aware of any way to get around that without basically forcing the node to become primary, but then, of course, then it allows writes, and that will really cause a split-brain problem.
Okay. Next question. Can the MySQL database be used in PXC, and are there plans to improve MySQL support in general?
Another perfect question. Okay, so the system databases store grant information, as most people know. The things that are replicated by default in PXC in the system table are not, you can't do direct DML against MyISAM tables. It's not enabled by default. For system table stuff, if you use grant, create user, drop user, commands like that, I forget what the D, it's D something L. Anyway, those commands, all the nodes, but if you do a direct insert, update, delete on one of those tables, that will not get replicated by default. MyISAM replication is a tricky subject, and really, what I'm telling people is, look, MyISAM replication is really never going to be any better than it is now. The reason for that is with the transactions and the write sets, we have the ability in Galera and Innodb to actually roll things back if they're going to conflict with something we're trying to do. So we have one inbound transaction that has committed, we have something else conflicting with it, we can go roll that back. We can't do that in MyISAM. So the only way to even remotely safely replicate MyISAM in the cluster is to basically stop the whole cluster, do your MyISAM, it does it as statement-based replication, and then it resumes the cluster. So what I tell people is, look, if you're trying to get away with doing everything in MyISAM in the cluster, this is almost certainly not going to perform the way you want it to, and it's really not going to ever get any better because there's really no way to implement the features that they implemented in Innodb to support this kind of replication to be performant in MyISAM because it just doesn't have the concept of transactions. So that's the unfortunate answer. As we move to 5.6, the system database is moving over to Innodb. So that's really going to, I think, be the end of MyISAM, in full text search and so forth. So I really don't recommend you use MyISAM in PXE. If you do, recognize it's never going to get better, so don't deploy on the assumption that it will. And even if you do, make sure that it's really just a very small set of tables that you have to do in MyISAM because it's full text or something like that in 5.5.
Okay, and we have time for one more question, and I just want to remind everyone, if Jay doesn't get a chance to answer it, he will certainly answer it in his follow-up blog post on MySQL Performance blog. And Jay, the last question is XtraDB Cluster usable in larger WAN clusters with high latencies like US, Europe, Japan?
Yeah. So it all depends on how you define usable, doesn't it? The real penalty for PXE in large network latency links is going to be the commit time. So the nice thing about it is that you're only going to take that penalty, you're going to take that high latency penalty on commit. It's not going to be while you're busy doing your transaction. Now, that being said, of course, it might be easier for other nodes and other locations to have writer conflicts, and then you've got this larger window where those kind of conflicts can happen because of that latency. But in general, it actually works pretty optimally considering the distances involved. The penalty is really just one round trip out to all the nodes and back. The math we generally do is say it's the worst round trip between any two nodes in the cluster is going to be about your commit penalty. So that's pretty darn efficient. And for small transactions especially, that's going to be good. Now, I had an example of a customer who was experimenting with a WAN cluster, and it was a UK, East Coast US, West Coast US, and they found they had this process that went through and did a whole bunch of work, and they found that as they kept adding nodes to the cluster, they had one node in the cluster that performed normally. They added two nodes to the cluster, it jumped up from a second to 9 seconds, and then when they added the third node, it went up to 18 seconds. And we're like, well, what's going on here? And I started thinking about how does this work and whatever, and I finally went back and looked at what their application was doing, and it was auto commit. So every single statement, it was like 100, 130 statements that were all committing every time and incurring that penalty. Now all they had to do was make that one big transaction, and that went back to almost zero. So there are people running WAN clusters in production. It's definitely not as many as the LAN. In general, I think people are finding it actually works fairly well, but certainly, it's all about whether or not that write penalty is going to be problematic for you or not, and it's also about your larger, global deployment strategy, global deployment architecture. Your application sitting on top of this cluster, how that's going to behave when these nodes maybe get disconnected, go non-primary, things like that happen. You want to make sure that the whole stack is going to be prepared to deal with that. So I think that's the best answer I can give for that, and I think we're about out of time. Right, Lisa?
Yes, everybody, thank you so much for attending our webinar today. Jay, thank you very much for a great webinar. And I will be sending out a recording link to this webinar within 48 hours. And everyone have a wonderful evening or a wonderful day. And thanks again. Hope to see you again soon.
Thanks all.